got it? Okay, so I want to get the last thing started today because of I don't know what Friday is gonna bring. So I want you to go to page 69 on expected value. Yeah, 69 on expected value. So I'm just gonna get it started today, and then hopefully on Friday I can do a little bit more on this. So expected value, it is an application of probability that involves the likelihood of gain or loss, and it is stated as a dollar amount. Okay, expected value ends up being a dollar amount. It is relevant in business, insurance, and in many situations in your daily life. The concept of expected value is used to determine, right? It's used to determine whether or not to participate in games of chance, whether or not it is a good idea. The expected value is only accurate, right? Only accurate in the long run after playing many games, right? So in other words, you would need a large sample size. You can't just say, let's say we get a result where you expected to gain, you go play, and you lose the first game. It's not accurate. Page 69, Andre. And here's the formula, guys. I would have this formula on my study sheet because the formula on the actual formula sheet, the green one, is not this robust and it's not as detailed. So this is your expected value formula. Okay. And I will just quickly show you where it is on your formula sheet. It looks quite different. I would say you should have this on your study sheet under probability, okay? So make sure you copy it. So here it is. Expected value is probability of win times gain minus probability of losing times the loss you will incur. That's all you have there. And this one, look at how this one has the ... in between. When you're playing a game, there could be many ways of winning a prize, or if you're entering a draw, or if you're buying lottery tickets, there are many ways of winning. There isn't always just one way of winning, one prize. There are many prizes. So the probability of winning the first prize would be prize minus cost. This is what we call gain. This is the gain for the first prize if you were to win. So let's say the prize is $1,000, right? The price, and you spend $100 on the ticket, you're actually gaining $900 in your pocket, right? Your wallet will only have grown 900 because you gave 100 away to win 1,000. So 900 is your gain. Plus, there might be another way of winning, a second prize. This would be, then you take the prize that you win there minus the cost. That's your gain number 2. Plus, ... right? Like there could be many more ways of winning, but at the end, you have to make sure you account for the losing part at the end. That has to, and there has to be a minus, right? So watch for minus, right? So you go plus everything, but then there will be a time where you have to subtract, because obviously if there's probability of winning, there's also losing, a chance of losing. I'm going to use a different highlighter. Look at the sign to determine what is going to happen. Okay, so if you have a positive answer, you plug in those numbers and you get positive, then gain is expected. You would consider it a good idea to play the game or invest in it, because sometimes contractors will put a bid in, like when the province makes these big projects, like when they build bridges, when they build roads and stuff, companies actually put in a bid. They're like, this is how much we would do the project for. And another company might say, hey, we will do it for this much. And everybody puts in their plans. But you know what? They spend thousands of dollars developing their plans. They can't just say, hey, I'll do it, pick me. No, the province wants to see, okay, did you do some work? Did you like calculate this? So they had to hire engineers, they had to hire, you know, geoscientists, they had to like do a bunch of research before they present the project. And so they're basically technically buying a ticket, hopefully to win the contract, right? So it can be applied there too. So the expected value could be 0. It's a fair game. You break even. Your choice if you want to play. You will overall not really be ahead of the game. You'll be losing sometimes and winning sometimes. But if you have a negative answer, loss is expected, we would say it's a bad idea to play or the game or invest. We would say don't do it. The value calculated for EV, expected value, is the average amount you're expected to gain or lose per game or bid. Only true in the long run again, and it will not work out if you only play a couple of games. So large sample size. Large sample required. Okay. So let's dive right in and do a question. Maybe I'll just give you some examples. Honestly, if your answer is 0.01, like 1 cent positive, we would still consider it a good idea to play in this course. If your answer is negative, like 1 cent, it'll be a bad idea to play. Right? But it could also be negative 2,450. That's also a bad idea to play. So how big the number is doesn't really matter. What matters is the sign. Yes. That is where it's at, right? So negative, no good. 0, your choice. I don't think 99% of the time it'll either be negative or positive, not 0. Okay, but it does happen from time to time. So let's do a calculation. Let's put this formula to the test. Please add this formula to your study sheet. Write it somewhere on there, add to study sheet so you don't forget, okay? The province usually has an expected value question in it. They usually do. Mr. Dixon, what if there's only one way of winning? And so then you just omit this part. If there's one way of winning, don't worry about anything else. You just have to make sure you subtract the probability of losing. So if there's a 40% chance of winning, there will be a 60% chance of losing. Just as simple as that. 1 out of 4 chances of winning, that means 3 out of 4 chances of losing. So keep that in mind. Let's go to 70. Sometimes I overdo it with the theory. I should just jump into the examples and then later talk more about the theory, right? So here we go. At a game at a summer fair consists of drawing marbles from a bag. A bag contains 10 red, 30 yellow, and 60 white marbles. How many marbles in total? That's total 100, right? We're still in probability, probably a good idea to do that. Watch this. If you draw a red marble, you win $25. If you draw a yellow marble, you win 7. And if you draw a white marble, you get nothing. You essentially lose, right? Let's put down lose or a loss. So this would be prize 1, and there's a second prize, right? Prize number 2. This would not be a prize because you get nothing if you draw a white one. It costs $3 to play. Let's highlight that. I'm going to highlight the 3. It costs $3 to play the game. That is important here because it's going to show up again and again. So here we go. Expected value in this case would be probability of winning the first prize times prize 1 minus cost. Is there another way of winning? Yep. So we're going to go plus probability of winning the second prize times prize number 2 minus cost. You always subtract the cost. Is there another way of winning? Nope. So we go minus, make a minus like that, probability of losing times the cost. Oops, I miscalculated my space there, but it's still gonna work. Let's plug in now. EV, not electric vehicle, okay? It's expected value. What's the probability of winning the first prize? Make sure you follow along up here, right? When you draw a red, you win the first prize. So the probability of drawing a red is 10 out of 100. So let's write that down. 10 out of 100 times the prize is 25 bucks, but you paid $3 to play. So you have to subtract it because you're only gaining $22. The probability of winning is 10 out of 100, and what you're really gaining is $22. Plus, it's the probability of winning the second prize. Let's go up here. It's when you draw yellow. There are 30 yellows, so we're going to go 30 over 100. You can win $7. We subtract the 3 that you paid to play that game. Minus, what's the probability of losing here? It is 60, right? But let's say you didn't notice that. You just go ahead and take 100, subtract 30, subtract 10. Right? So there's a 60% chance of losing. The question also tells us that by saying if you draw a white marble, which we have 60 of, you lose. And in this case, all you put down is the cost, no minus, okay? It's just the $3 there. And I want you to highlight, because this is the step that a lot of students miss. The fact that the cost appears in every single one of those expressions. If you plug it in correctly, you get a significant amount of marks already. I'm just going to leave everything. I'm going to leave the 10 over 100. 25 minus 3. This could be a decimal, okay? So 25 minus 3 is 22. Just put 22 in there. Plus, I'll leave that. 7 minus 3 is 4. Minus 60 over 100 times 3. That's already cleaned up, so I'm just going to leave it like that. And here's where you grab your calculators. I do not want you to type that in one shot. Not that like cosine law, right? It's not like that. So we're going to go, follow me, 10 divided by 100. I'm going to hit equals there. And then I'm going to multiply that by 22. And I'm going to write down all decimals, right? So that gives me 2.2 plus clear my screen. 30 divided by 100. I multiply that by 4. That's 1.2 minus 60 divided by 100 times 3. It's 1.8. And now you can do it all in one shot if you want. So I'm going to go 2.2 plus 1.2 minus 1.8. Is that a positive number or a negative? By definition, it's positive, right? Unless the calculator puts a negative in front. So you need to make sure you put a dollar sign to get the right answer. If you want full marks, expected value is a dollar sign. So it's $1. That's not quite right. You have to include the 0 here. Make sure that is included. So you're expected in the long run. So if you were to play, 500 or 1,000 games, you would expect to win $1.60 on average. You would be gaining $1.60 on average. So make sure, right? Unit, rounding. You got to make sure you have that 0 there because your calculator will not show you that. Is it a good idea to play? Should you play this game? Justify referring to this answer. Yes, since the expected value is positive. That's what you answer. You don't say yes because the number is pretty big. Or yes, you shouldn't because the number is pretty small. Don't say that. It's positive, right? It's the sign that you're after. If you were to play 125 times, how much would you expect to win or lose? We already determined that you're winning. So it'd be 125 times $1.60. $200. This is how you do expected value. I'm not going to have it on tomorrow's quiz though, but it will be on the test. So my goal is that if the quiz goes quicker than expected tomorrow, then we'll do a bit more on this tomorrow. If not, we're going to have to wait for Friday and continue with this on Friday. So for tomorrow's quiz, right? Pages, what did I say? 54 to 68, I believe. Right? 54 to 68. I will post the key entirely, all worked out. So even if you, I think you shouldn't just flip through it. You shouldn't just look at my answer keys like, oh yeah, I got it. You should actually try it and then check the answer key. Because otherwise, it's not really going to help you a whole lot. One more thing before I let you go and pack, okay? Come with me to, you remember the total number of outcomes when we did the tables, the outcome tables? I'm going to expect you to know how to do one of these. One of the dice outcome tables. I think I did a 6x6 with you, right? I made a mistake and I just fixed it. So anything 4x5, 6x6, you should be able to fill that in and answer questions. This is page 40. Yeah. So you should be able to do that. So for example, if I gave you one like this, you should be able to fill that in. Like if it's already I already tell you this is a 5-sided with a 4-sided, right? This would be 1, 1, 1, 2, 1, 3. And then you should be able to answer, what's the probability of getting a sum of 6? Or what's the probability of getting a sum greater than 4? Stuff like that. You should be able to answer that question, okay? And the keys are posted. I believe you go back to Monday Monday's posting, it's there. Okay. Thank you guys.